Hello everyone and welcome to a new lecture. In this video we're going to talk about geometric sequences. In the previous lecture we talked about arithmetic sequences, and we saw that in order for us to create the next term in an arithmetic sequence we have to add it to a fixed value that is called the common difference. Okay, here let me give you a couple of examples of geometric sequences first. So this list of numbers, so 10, 30, 90, 270 and so forth. Also, if I have 2, 4, 8, 16, 32 and so forth. As you can see here, I'm not adding, so if this is a1, I'm not adding a value to a1 to create a2. It's not the same thing that I add in order to create a3. Okay? However, what I do is I multiply. Okay, so from A1 to A2, I multiply by 3. From A2 to A3, I multiply by 3. From A3 to A4, I multiply by 3. Okay, the same goes for here. From 2 to 4, I multiply by 2. So instead of adding to a fixed value, I multiply by a fixed value. Okay, from 4 to 8, I multiply by 2. From 8 to 16, I multiply by 2. From 16 to 32, I multiply by 2. Okay, so instead of having a common difference, I have something that is called the common ratio. So these are called common ratio. Okay, and the reason is because if I divide, so for example right here, if I divide, this is a1, this is a2, this is a3, this is a4. If I divide a4 by a3, I'll get a number which is 3. If I divide a3 by a2, I'll get the same number, 3. If I divide a2 by a1, I'll get the same number, which is 3. Okay? If I divide 32 by 16, I'll get 2. If I divide 16 by 8, I'll get 2. If I divide 8 by 4, I'll get 2. And if I divide 4 by 2, I'll get 2. So the term or the fixed value that creates all the terms in this sequence is something that is called a common ratio. It's a common ratio between all of them. Okay, so that is basically what the geometric sequence is. Okay, so how can we find the nth term in a geometric sequence? Well, basically the rule is, so in order for us to find the nth term, or to find x with the subscript of n, basically what we're gonna do is we will have the first term, okay, multiplied by the common ratio raised to a power of n minus 1, n being the term that you want to find. Okay, so this a right here, this is the first term of the sequence. The first term. This r right here, this is the common ratio. And a right here that we have, this is the term that you want to find, and minus 1. So let me give you an example. Suppose I have this sequence. It's a geometric one, okay? So suppose I tell you that the common ratio for this geometric sequence, so r equals to 2, okay? The first term of it equals to 3. And I ask you to find me the fifth term. So find me the fifth term. Okay, how can you go about solving this problem? Well, we're going to use this equation in order to do so. So x with a subscript of 5 equals to the first term, which is 3, times the common ratio, which is 2, raised to a power of 5 minus 1, since we are trying to find the fifth term. So here we have multiplication. And this is the same thing as 3 multiplied by 2 raised to a power of 4. Okay, this is the same thing as 3 multiplied by 2 to the 4 is 16. 3 times 16 equals to 48. So the fifth term of this geometric sequence equals to 48. Okay, let me give you another example. This example is a bit harder. Suppose I tell you that the third term, so the third term, so this is example 2, of a geometric sequence equals to 63 over 4. Also, the sixth term of a geometric sequence equals to 1701 over 32. And I ask you to find me the fifth term equals to what? Okay, so how can you go about solving this problem? Well, if you remember, we did something in the previous lecture for arithmetic sequences is we created equations, okay, and then we subtracted from each other. We got the values of the unknown, and then we put it back into the equation of finding the nth term, and that's how we found the nth term. Here we're going to do the same thing, however we're going to tweak it a little bit. Okay, so the third term equals to 63 over 4. So let's write the equation for that. So the third term, or 63 over 4 equals to a times r. Okay, the 2 right here, because it's 3 minus 1, we're going to get 2. This is our first equation. Our second equation is going to be 1701 over 32 equaling to ar to the power of 5, because it's going to be 6 minus 1 is going to be 5. Okay, so we have two equations. Okay, so what we're going to do is, instead of subtracting it from each other, we're going to divide. Okay, we're going to divide the equation such that it has the highest power by the other one. Okay, because that makes more sense. Okay, so if I divide, I'm going to have something like that. So equation 2, so here, this is equation 2, sorry. So equation 2 by equation 1, I'm going to have ar to the 5 over ar to the 2 equaling to 1701 over 32 divided by 63 over 4. Okay, so let's see what can go away. So this a gonna go away with this one. This r to the 2 gonna go away with this r. However, we're gonna be left with r to the 3. Okay, and we can do this division. However, we're gonna be left with 27 over 8. So we will have 27 over 8. So from this, we have r to the 3 equaling to 27 over 8. Okay, I can take the third root of both sides, and I'm going to have r equaling to 27 is going to be 3, under the third root 8 is going to be 2. So I found the common ratio. Okay, this is one of the unknowns. I have to find the first term, meaning a. Okay, all I'm going to do is going to plug this r into the first equation. I'm going to get a. Okay, so let's keep it like that. So 63 over 4 equals to a times 3 over 2 to the power of 2. So from this, we will get 63 over 4 equaling to a times 9 over 4. This 4 and this 4 gonna go away. This 9 gonna go away, and this 63 is gonna be 7. So a equals to 7. Okay, very, very cool. Now we have all the information that we need in order to find the fifth term. Okay, so let's find the fifth term. So the fifth term equals to, so x with a subscript of 5 equals to a equaling to 7, times r equals to 3 over 2. And then we have a 4 right here. Okay, you can do the multiplication. However, this is 567 over 16. Okay, this is the fifth term of this geometric sequence, such that the first term of it equals to 7 and the common ratio equals to 3 over 2. Okay, and with this we come to the end of this lecture.